Hello everybody, let's talk about section 4.3, which is on logarithmic functions and their graph. And in this section we're going to go over what we mean by that. Of course, we want to start talking about the inverse of the exponential function. In reference to section 4.1, we talked about inverse functions, and so now we're going to apply that to our exponential function. We're going to use that to help us get a definition of a logarithmic function. We'll go over some graphing of logarithmic functions, what's meant by the natural and the common logarithm, and domain and range of a logarithmic function. So the first question I have for you, of course, is to ask you, what is the requirement for any function to have an inverse in the first place? Well, maybe you remember this one or not. I'm going to pause for a second and you think about that. Maybe you can flip around in your book for a second. So what was it? Well, that requirement for us is that our function must be one-to-one. So whatever function we're looking for having an inverse must be one-to-one. Now, what did that mean? Well, a one-to-one function was the kind of function that if we were to look at its graph, would be the kind of function that would pass the horizontal line test. If we were to draw a horizontal line through our graph at any point of the function, it would pass through in one and only one place. And so this is an important aspect of this, and we can say that each value of x is assigned exactly one value of y, and each value of y is assigned exactly one value of x. So this particular function, y equals 3 to the x, is a perfect example of a one-to-one function, because for any one value of x that I substitute into the function, I get one and only one value of y. Raising 3 to the first power only gives me positive 3, and can only give me positive 3, and that's true for all of my values of x and y. So let's look at this function. F of x equals 3 to the x. What's its domain and range? Well, in the last section of chapter 4, we established that the domain of a function like y equals 3 to the x is all real numbers. So all real numbers from negative infinity to positive infinity are covered right here. We can get negative values for x. We can put in 3 to the negative 10th and get 1 over 3 to the 10th. How about the range? Well, the range is going to be the set of all values, in this particular case, from 0 to positive infinity, not including 0, because if you remember, one of the things that we have to be able to do is to get a value of 0 if we were to include it in the set, but 3 can be raised to no power to give us 0, nor can it give us a negative number. The closest we can get are numbers that approach 0, but that's about it. So if we're interested in finding the inverse of a function f of x, y equals 3 to the x, how did we do it? Well, you recall from our earlier section that the method went like this. For finding any inverse function, we replace f of x with y. Then we swap x and y. So x is equal to 3 to the y, and then we have to somehow isolate y out of this entire equation. Well, that's really the subject of this particular section. What do we do to isolate y? And that is the basics of what we call a logarithmic function. And we'll get into that in a minute, but if you remember, the way that logarithmic functions worked was that these were the way that exponential inverse functions work was that any value that we had in our function where we had a coordinate point, we reversed that coordinate point on our inverse. So on our function y equals 3 to the x that passes through the point 0, 1, our inverse must pass through 1, 0. Must also be the kind of function that instead of passing through 1, 3, passes through the point 3, 1. Instead of passing through a point like 2, 9, it would pass through the point 9, 2. and so on. So if we were to graph this particular function, this inverse function, we would get something that looks like this. And you might already have spotted my logarithm expression down there at the bottom. We'll talk about that in a minute. How does this all work? But that is what our inverse function will look like. So whatever our function actually does, if we have y equals f of x for this first graph right here, we're going to have y equals f inverse of x with the second graph.